by graphing. Ooh, sorry. That's messy. What do you mean? Oh, she just pulled one over. You're good. Okay. Do you know what a system of equations is?
Is that like the X and the Y columns?
No. Okay, so it's two or more equations, makes up a system of equations, okay? And you can solve a system by finding the values of the variables that would make all of the equations true. So we're looking for, in most of these cases, an X value and a Y value that will make, we're gonna do two equations, so that will make both of our equations true, okay? You're solving a system, trying to find the overlap, okay? So here's how we're starting. There are three types of solutions that you need to know about. Okay, one is gonna look something, actually, let me just draw all three grids first. Okay, so let's say one of them looks like this. You have a line here, and you have a line here, okay? The solution to this system right now is the intersection. It's the point that they meet. So this right here is my solution. When they meet at just one point like that, we say that is independent. Which means there is one solution. Your solution is a point, x, y. Basically, what you need to think is you have different lines. If you have two different lines, they are independent, it's one solution, your answer is x, y. Good. Second one is if it looks like this. So you have two equations, but only one line. That's because the two equations got you the same line. So this one is called dependent, which means you have an infinite number of solutions. Okay, because they're the same lines, right? So if I have two lines that are on top of each other, they are the same line. That means every point on that line is a solution. So we have an infinite number of x's and y's that will work out, okay? So that's dependent. And then the last one is if you have something that looks like this. First of all, how many solutions are you going to have if you have parallel lines? Zero. There's never a point where they meet, right? And we're looking for a point where they meet. So this one we call inconsistent. Which means there is no solution. And that's because you have parallel lines. Okay, questions on any of those? All right, let's get to it. So example one here, we are going to solve by graphing. So your system, and I'm going to color code these so that you see which equation goes with which graph. Sam, would you like to pick my colors?
Just don't use red and green.
So if I use purple and blue,
I don't care what you use, just don't put them on the same one.
red and green.
It doesn't become invisible, I just don't know what's line.
So if I use purple and blue,
I can't tell that.
you cannot tell that one. Purple and green?
That'll work.
Yeah? Okay, purple and green. Okay, so here's our system. Y equals x minus 1. And y equals negative x plus 3. Okay, so we're going to start with the top line, the green line here. That is our system. How do I graph y equals x minus 1? You go down 1. So this is my y-intercept. Okay, and then from there, you're going to go a slope of 1, right? Your slope out in front is a 1. You don't see it, but it is. So up 1 over 1, up 1 over 1, up 1 over 1. Technically, you only need 2 points, but I feel like if you do more points, it just helps you be a little more accurate with your graph.
Which line are we graphing right now?
The top one.
Okay.
Y equals x minus 1. Okay, so there's that line. The bottom line, what do you plot first? Plus 3. So from 0, 0, 1, 2, 3 is here. And what is your slope? Negative 1. So you're going down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and then drawing that line in. Thank you. Okay, so my question is, what's your solution? It is the point where those two lines meet. So this right here is your solution, and that is the point 2, 1. Okay, so that's your answer.
So, for the slope from the line,
You're going down 1 over 1. Yeah. Down always to the right. Okay? All right. You love these kinds of what?
I love like when it intersects. So,
I know, it's gratifying, right? Yes. Okay, second one. If this is your system, oh, sorry, caught my line. 2x plus y equals 4. And x, oh, we were going to switch colors. This is a new problem. X minus y equals 2. So we're going to graph on the one right below it here, okay? Okay, so first of all, you have options for this, right? We could turn this into slope-intercept form, but you risk making a mistake turning it into slope-intercept form, and it's just more work, right? Instead, what you could do here is the cover-up method. So if we start with our green line, the top line here, we would say cover-up method is 2x equals 4. So divide by 2. That's going to mean our x-intercept is 2. Okay, and then your second equation is y equals 4. There's nothing to solve for there, so that's our y-intercept. So you're going to plot an x-intercept of 2, a y-intercept of 4, so up y, 4, over to the right, 2, and then draw that line in. How are we doing? Still with me? Okay, so for our purple line, again, it's in standard form, so do the cover-up method. Your two equations are x equals 2, so that's your x-intercept, and then negative y equals 2. So if you divide both of those by a negative 1, or multiply by negative 1, you could do either way, your y value should be negative 2. Okay? You're going to plot those as intercepts. So x equals 2 is here, same as that first one was. Y equals negative 2 is here, and you draw that line in. Okay, what is your answer? 2, 0, right? This point right here is your solution. You write it as 2, 0. Questions on that? Is this all coming back to you?
Yeah.
But I don't remember learning it.
You don't remember learning it? For real? Chapter 6. It was all chapter 6. Okay. Of Algebra 1. So 2 years ago. So maybe that's why. It's been a while.
What happened last week? I still don't remember too.
Okay. Here's your next system. X equals -4. Y equals 1. First of all, the beauty of a problem like this is you can tell me your answer without even graphing it. So your graph is just you checking your answer because X equals is what kind of line?
That's a.
It's vertical. Y equals is horizontal. So where a vertical and horizontal meet is going to be at the number that's given. So your answer is -4, 1. Oh, I did red and green. Sorry, dude. My
I
bad.
can kind of tell. The first time I saw it, I was like, yeah, that's one color.
Sorry.
I looked back at it and I was like,
I'll go purple.
because Piper wanted to make fun of me.
Okay.
He's like, which was which? And I looked really closely and it's like, the top's kind of green, the bottom's kind of red.
Okay. Well, I'll work on it. So X equals -4, that's a vertical line where X is always -4. So you're going to move on X, 1, 2, 3, 4, back 4, and draw this line in. Okay, that's X equals -4. The line Y equals 1, that's a horizontal line at 1. So that's there, right? Your Y value is always 1. So your answer, your solution is this point, which is the point, -4, 1. So if you have a horizontal and a vertical like this, it's a pretty quick solve. Questions on that? Okay. Last one, graphing. And then we're almost done with this first one. This system, you have -3x plus 2y equals 8. And x plus 2y equals -8. Okay? Now here's the deal. With that top equation, if you do the cover-up method, you end up with a -8/3, which is just not a pretty number to work with. So what I would do if I were you on this is I would turn that top one into slope-intercept form. Okay, because otherwise you're kind of guessing where you fall because it's a fraction. If it's a half, that's okay. If it's thirds and all that, then it starts to get a little bit off kilter and you might miss your actual answer. So what I would do for that top one is turn it into slope-intercept. So you get 2y equals, add the 3x, so 3x plus 8, and then just divide by 2. So really it's y equals 3/2 x plus 4. So I would graph this one instead. Okay? For that, you're going to go up 4. 1, 2, 3, 4. And then your slope is 3/2. Where do you move for 3/2? Up 3, always to the right. Okay? If you go up, still to the right. If you go down, still to the right. So up 3, 1, 2, 3, over 2 would put you there. And then when you draw that in, oh, I missed. Is that going to line up okay? We'll see if it lines up right for us because I didn't draw that line very nicely. Precision is key on these, by the way, so that you make sure you match up. Okay, this one, the second one, I don't think you need to put into slope-intercept. You're welcome to, but it's more work. You can easy do the cover-up method on this one. So if I say x equals, that's going to be -8. Your second equation is 2y equals -8. So your y-intercept is -4. Okay, so those are your two intercepts. So if you plot them, 1, 2, 3, 4, 5, 6, 7, 8, puts you there. And then -4, 1, 2, 3, 4, puts you there. take your ruler so you know you're getting the right answer. Yeah, so I kind of missed on my graph a little bit, but it's just because I have a janky ruler going on. So my answer should be this point right here, which is 1, 2, 3, 4, 1, 2. So -4, -2. Questions? Okay, can I keep going?
Yeah.
All right, second final thing that you're gonna do. You are going to classify your graphs without graphing. Okay, so thinking back to those first 3 pictures that I drew for you, the whole dependent, independent, inconsistent, that's what you're going to be classifying. So one option is independent. Do you remember what independent meant?
1 point.
1 point. You had 2 different lines, right? Okay, so that's one option. They might be dependent. Do you remember what that one was?
Same line.
The same line, one line. Or they might be inconsistent, which would mean you have parallel lines. Okay, so I'm going to give you a system. You tell me what this would be. So if I give you y equals 2x minus 3 and 6x minus 3y equals 9, okay? Your best bet for these is slope-intercept form because it'll tell you the slope and it'll tell you the intercept, which is how you can tell if they're parallel, perpendicular, neither, same line, different lines, all of that. So this first line is done. You don't need to do anything with y equals 2x minus 3, but let's take the green line and turn it into slope-intercept form. So we're gonna subtract 6x. So it's going to be negative 3y equals a negative 6x plus 9, right? We're just isolating the y. To do that, we got to take one more step and divide by negative 3. Make sure you're dividing by negative 3 everywhere, okay? So this is 1. So it's y equals, what's negative 6 divided by negative 3?
2.
Positive 2, good. So 2x. 9 divided by negative 3?
-3.
Negative 3. So here are my 2 equations. Y equals 2x minus 3 and y equals 2x minus 3. Can you classify that for me?
Dependent.
That is dependent because that's the exact same line. Okay, so your answer here would be dependent, right? Because it's the same line. Questions on that? Okay, last one of those. We'll call this B. If I give you 8x minus 4y equals 20, and then y equals 2x plus 3, what should you do in this setup?
Change the first equation to slope-intercept.
Right, so we're gonna take the 8x minus 4y equals 20 and put that into slope-intercept form. So we're gonna subtract an 8x, so it'll be negative 4y equals negative 8x plus 20. What's your next step? We wanna,
Divide by -4.
right, we wanna isolate the y, okay? So divide by negative 4, divide by negative 4, divide by negative 4. So you end up with y equals 2x minus 5. Okay, so you have that equation. Here's where I think color coding is just a good idea because now you can see your 2 equations, right? The black ended up as that. The green, oops, is this one. Look at those 2 equations. What do you know about them? They have the same slope, but
The first line
A different y-intercept. So if they have the same slope and a different y-intercept, they're parallel, right? So your answer here is what? How do you classify it? Inconsistent. Because they are parallel. Okay? Questions on that?